Okay, everybody. Yeah, we do got some audio here. Good morning to all of you. I hope you guys are doing well. I'm just trying to still get some stuff up and running here for you guys. So let's double check. Yeah, it looks like we're good to go. So good morning to all of you. So what I have for you guys today is we are still solving trig equations. But this time, we have to use a little bit of some what? The purple comes out. What's this word? Algebra. Okay, so the first one here, if you guys notice, we're trying to solve, a couple of these examples using some algebra. We're trying to solve a trig equation that has a power 2, right? Okay, so you guys see what we're saying here. Now we got to use a little bit of algebra. So in order to do that, here's what I'm going to say to you guys to do. Right, we're going to do what's called a substitution as we introduce the algebra. So we're going to say let t be sine of the function. If you do that, notice you get what? 2t squared minus 1 equals 0. Because what you're going to do is still solve for sine. Okay? But we got to do a substitution now. So t here is going to be our sine. And when you let t be sine, you get the equation 2t squared minus 1 equals 0. Now, this is what I mean by algebra. So let's ask you guys a question here. Do you remember a little bit of algebra here? Anybody know what I'm talking about? Right? What do you guys do to solve this? Do you guys remember? Yeah, we actually already worked on some of this algebra. Let me actually share with you guys what the algebra is here, right? Yes, we solve for t here. And this is what I mean, how we've already really done this here. Okay, this is the algebra we're talking about. Okay, so you get this t squared equals 1/2. Are you guys okay with that one? Now, what do I mean by we already did algebra here? Do you guys remember? What am I talking about? How do you guys solve this equation? What do you guys do to solve for t, right? We've done this before. We actually did this in the beginning. What do we do? What do we use? What's it called? What do you guys use? It's use the what? What is it called? Yes, the square what? Root formula. So when you use the square root formula, we get t is plus or minus the square root of 1/2. Okay, you guys okay with that? Right? Isn't that the square root formula we already talked about? We already did. Okay, now though, what we're gonna use here some more algebra. You say, what do you mean here? Well, isn't this the square root of 1 over the square root of 2? Which is 1 over square root of 2. Okay. So the t now that you get is going to be what? There's two answers for t. Now I'm going to keep this denominator. I'm not going to rationalize the denominator. I'm going to keep it. Right? Because now this means what? These are two things, right? In one case, it's positive, and in the other case, it's what? Negative, right? Because this is plus or minus. Okay, so what was t to begin with? Do you guys remember? Right? We're trying to solve this 2 sine squared minus 1. You're going to use a substitution where t is what? We let t be what? T is going to be sine, ladies and gentlemen. So now you say, but t was sine. Yes, t is sine here. So sine is 1 over the square root of 2, and sine is what? Negative 1 over the square root of 2. So ladies and gentlemen, this is what the algebra is going to give us. It's going to give us multiple solutions here. Now remember, this is find all solutions, so we've been doing that. Okay. All right, you guys okay with that? So here's what we're going to have to do. So let me ask you guys now. I'm going to say, what do we do now? What did you guys do last week with this? What did you guys do? What do we do with this information? Anybody know? What do you guys do? Because remember, you have sine here being what? Positive, and over here we have sine being what? Negative. All right, so what do you guys remember? What do we do? You always bring out the what? You bring out the reference angle. So, you know, I've been using purple for the reference, if you guys remember that. We've been using purple, is that right? And the reference angle is always that positive angle. It's quadrant 1. I'm going to bring out the all students take calculus soon, but we're going to have to do some what? You guys remember? What do we do? Here's my what? Opposite over what? Hypotenuse. So what special triangle is this, right? This is a special triangle, isn't it? Which one is it? Yep. Remember, there's only 2 special triangles you guys have to know. Is that right? This is 1 square root of 2. So that means the reference angle, this is the reference angle. This was 45 degrees. Pi over 4, ladies and gentlemen. Okay? Remember, this is your reference information. Okay? Okay, so this is reference. Now, ladies and gentlemen, let's bring this in here. All students take calculus. Now, notice this here. I want you guys to go back. We're going to see this is going to be something very interesting here. Right? Because remember what I'm saying here. All of this reference is quadrant 1 in purple. This is what you just found. You just found that the reference angle here, okay, that this angle is pi over what? 4. All right, you guys okay with that? Now go back to the original kind of situation we're talking about. I'm going to have to move all this over because it looks weird to me. I always do that. Sorry. Okay. Now remember I said you had sine is positive and sine is negative? Okay, so we're going to have to identify where sine's positive and sine's negative. In fact, you might say, you know, Mr. Judge, that's all 4 quadrants. Well, you're right. It is all 4 quadrants, right? You say, what do you mean all 4? Well, sine is positive in quadrant 1 and quadrant what? 2. Is that right? Sine's positive here and here. So for the first set of solutions where sine is positive, this again is your what? That's your reference angle. Is that true? So what's the quadrant 2 solution, right? I wrote it down last week. The quadrant 2 solution is going to be what? Isn't that pi minus the reference angle of pi over 4 from last week? Is that true? Right? Quadrant 2, isn't this what you always do? Now do some arithmetic. You say, what's my arithmetic? Isn't that going to be 4 over 4? Right? You get 4 over 4, and then this is going to be now what? What's your angle? Isn't this going to be what? 3 pi over 4? So, ladies and gentlemen, your two solutions where sine is positive is pi over 4 and what? 3 pi over 4. This is where sine's positive. All right, so we've taken care of the first situation. We have to now take care of what? The second situation where sine is negative. Okay, you guys okay with that? What do you guys think? Is that okay? All right. So where is sine negative, ladies and gentlemen? Which quadrants is sine negative? Right? You can see it in the picture. All students take calculus. That means quadrant what? 3 and quadrant what? 4. So sine is negative in these two quadrants here. Pi over 4, what else? Pi over 4. So sine's negative in quadrant 3, quadrant 4. So you're going to say, how do I get the quadrant 3 angle? Do you guys remember? Isn't that pi plus the reference angle of pi over 4 for quadrant 3? Ah, what happened? Oh, weird. And what about over here? Isn't that going to be what? 2 pi minus the reference angle for a quadrant 3 solution? Eight pi over 4 minus pi over 4, isn't this going to give us 7 pi over 4 over here, right? So take a look, ladies and gentlemen, and don't forget to do the arithmetic again for quadrant 3, right? Isn't that 4 over 4? We've done that arithmetic. So you're going to get, what is this, 5 pi over 4 here? Okay, so I just want to kind of remind people here that we found really the solutions in the restricted domain. Is that right? Quadrants 1, 2, 3, and 4. What they want is the general solution because they want all solutions here. Remember this? Find what? All solutions. And all of these are using some algebra. Algebra. Okay. So how do we find all solutions? Let's go back, okay? This is going to be something that I want people to, I'm going to get rid of this stuff here so it doesn't look so busy. And now we got to generate all solutions. In other words, they want the I should say the what? The general form. Is that right? Because they said all solutions. So how do we get the general form for all solutions here, right? Okay? Now, here's what I want to remark. It's very simple. It's going to be very easy. Do you remember what we talked about last time? Right? Remember this here? You see that first solution for x is pi over 4? I want you guys to notice this. If I have that first solution, I can get the opposite quadrant solution here. Is that true? So what I'm saying is quadrant 1 and quadrant 4, these are opposite quadrants where these angles here differ by what? They differ by pi, is that right? Okay, this is the key here. We got opposite quadrant solutions. So I'm going to take that first solution here, pi over 4, right? So if you're looking back at the book, they say, how did they do that? They just simply added a multiple of what? N pi, where n is an integer. And you say, yes, they did, because they have the opposite quadrants. Quadrant 1 and quadrant 3, they're opposite, but they share the same what? Reference angle here. So they do differ by what? Multiples of pi. Whether you rotate that ray clockwise or counterclockwise, you're going to get multiples of pi. All right, you guys okay with that? You're going to also notice that if you said, what if I took the other solution of 3 pi over 4, right? This 3 pi over 4 solution. Don't we have opposite quadrants as well? And the answer is what? Yes. So here you have opposite quadrants as well. In other words, if I get the what? The quadrant 2 solution, opposite quadrant 2 is quadrant 4, and they differ by what? Pi again. Is that true? So what you can say now is you're going to take what? The 3 pi over 4, and you're going to do the same thing. You're going to add the integer multiple of pi, and in fact, I could just use that one statement for both. And so, ladies and gentlemen, here you go. This is what you'll see in back of the book for what we call the general form, general solutions here. All right, you guys okay with that? These are all multiples of pi over 4. What do you guys think? You're not gonna see any other equations because you're accounting for all what? All these quadrants as solutions. They differ by pi now. They're opposite solutions. So what you did before with opposite solutions, you're going to do again. That's all. And, you know, they didn't ask for the sequence form. They didn't ask for this. But do you guys remember how to do the sequence form just in case? It's very simple here. I'm going to take that first what? Solution. And if I said, okay, how do we get the sequence form? Really what you're going to do is this. You're going to notice what? The denominator is 4. So what you're going to do is you're going to take 4 times the numerator, 4 times the denominator. They have the same what? Denominator. What can we do? Do some arithmetic. A over C plus B over C. Isn't that what? A plus B over C? Pi plus 4 and pi. This is now over what? Over 4. Okay, you guys okay with that? So if you said to me, well, what do they do now? Well, what they do now, I'm going to try to find another color. I don't know, maybe orange? They're going to factor out the multiple of pi over 4. Okay, we're going to factor out pi over 4 multiple. So what that does is I take this pi over 4, and you're left with 1 plus. You say, oh, there's a pi here. That's going to be 1 plus 4n. So this is the sequence form. They didn't ask for it, but I'm going to do one of them here for you guys just as a reminder that they're all going to be multiples here again now. And they're called integer multiples, where n is an integer. I can now generate all the integer multiples of pi over 4. And this is really the sequence part. If you said to me, what's the sequence part? Well, right in here. You know, you just take an integer value for n now, and you can generate all kinds of particular solutions that you want, you know. You go, oh, okay, I can get in all these particular values. But that's what you do for the first one. You also do for the what? The second one. You're going to do the algebra. So you say, okay, so what's the second one going to be again? So you can say, okay, x2 was going to be what? 3 pi over 4 plus n pi. So you're going to multiply the top by 4 and the bottom by 4. You're going to end up now again with 3 pi plus 4n pi, everything over 4, ladies and gentlemen. Just like before, this is exactly the same thing. Okay, you use the algebra we did up here. Same algebra. You say, do I factor out the pi over 4 again? Yes, you do. Factor out your pi over 4. These are going to be, again, integer multiples of pi over 4. So you might say, well, what's left? Right? The 3 is left, plus the 4n. So the sequence form here, ladies and gentlemen, again, n is an integer. This is the sequence part. And you just start to use different values of n now, ladies and gentlemen. But this will generate, you know, all those particular solutions that you need. And again, generally speaking, higher order math courses, you know, they do write it in sequence form. And, you know, you look at some particular solutions. But I just wanted to throw that out there for you guys. I know the book, if you're looking back at the book, I think it just gives you the general form. Is that true? But I just want to remind you guys there's a sequence form because, you know, sometimes other students use these videos, and that's okay. But this is your first example of how to use some what? Algebra. What do you guys think? Is that okay? Easy peasy lemon squeezy? It's just a little bit more work, but not much more. And we just have to remember just a little bit of algebra. What about the algebra for this next one? So if I just numbered these here, let's go back and say, let's look at some algebra here for these. Do you guys notice some algebra in some of those questions? All right, I hope you guys are taking a look at those. What kind of algebra did you guys notice in this? If you guys remember, let's do some algebra here. Let's do some algebra. Okay, now what algebra do we use here? Do you guys remember? Let me share with you guys some algebra here, okay? Right, here's what I'm going to say. If A times B equals 0, then what does that mean? Do you guys know? Do you guys remember this? There's a very famous property in algebra. What is this? Right? If A times B equals 0, what does that mean? And what is this called? Going back to some algebra. Right? Doesn't that mean two things? That means what? That means either A is 0 or what? B is 0. Is that true? Do you guys remember what this is called? What is it? What is the name of this fact from algebra? Anybody remember? What is this? This is known as the what? The zero product what? Rule. So if A times B equals 0, then either of those terms equals 0. This is called the zero product rule, if you guys remember that. That's or, by the way. Okay, do you guys remember this from beginning algebra? Now you might say, well, how do I use this, right? Well, if I said to you, maybe you can see that in colors. How do you guys use this now? Do you guys know? Orange and what? Green. What that means then is that forces us to say sine equals 0 or what? 2 cosine minus 1 equals what? 0. So notice this, ladies and gentlemen. Did I use the zero product rule? What do you think? We just set both of them equal to what? To 0, is that right? What do you guys think? Is that true? All right, so I actually do this, by the way. I put a little T here because what that T does, it separates your paper, right? So did you guys work on some of these over the weekend, I hope? Let's move it there. Okay. What I mean by that is, where is sine 0? Do you guys remember? Remember the graph? Got to draw a straight line. So hopefully you guys worked on some of these. You never want to wait till the night before, the weekend before. Okay? Never, never, never. Isn't this 2 pi? That's pi. 1 pi over 2, 2 pi over 2, and then what? 3 pi over 2? So where is sine 0? Where do you guys know? Sine 0 is going to be where? Remember this? Those were the intercepts. So when we talked about graphing sine, I asked you guys these questions. What are the intercepts? They happen when x is what? This one has what? Happens when x is 0, when x is pi, and x is 2 pi. Is that true? Do you guys remember this here? This is why I asked you guys in the beginning of the course, where is sine 0? This is what you guys did. Okay, you guys remember these here? All right. Now, what about this one here? Right? We've already know how to solve these. This is 2 what? 2 cosine is 1. Divide both sides by 2. So cosine's 1/2. Cosine's positive. Okay? So we're going to do the process here as well. Cosine's positive, meaning we're going to get that reference angle here. We need the reference angle. What's the definition of cosine? Adjacent over hypotenuse. What does that force my third side to be? Isn't that the square root of 3 then? What special triangle is this? You guys know? What about that special triangle? What's that going to be? What's the angle here? Yeah, I think this is going to be what? Right? Isn't that 1? This is 2? Is this 60 degrees? I believe so. Isn't that pi over 3? Okay, double check. Am I right with that? What do you guys think? Is that okay? Isn't that the 60, 60, 60? Special triangle? Double check because I'm not awake. Okay, now we bring in our what? All students take calculus. Is that right? So where is cosine positive? What quadrants do we mean cosine's positive? Do you guys remember? Well, this first quadrant, cosine's positive. We know about that. Okay, that's the whole point of the reference angle. This here is 60 degrees, right? Or pi over 3. So that's my first solution. But cosine's positive also in quadrant what? 3, is that true? Isn't that why we say all students take what? Or sorry, quadrant 4. Isn't that what we say all students take calculus? Okay, so this angle is also what? That's going to be pi over what? 3. So the quadrant 4 solution is going to be this solution. 2 pi minus what? The reference angle. 3 over 3. And what's that going to give you? That angle is going to be 6 pi over 3 minus pi over 3. Isn't that 5 pi over 3? So I want to remind you guys, or I should say more like warn you guys. They want us to find every solution here. Is that true? So what does that actually mean when I write the general solution? Right? They want the general solution here. Are you in opposite quadrants? Say no. Is this the opposite quadrant situation? This is not opposite quadrants, is it? So, I mean, we can start off by these and say this. I can start off and say, okay, x1 is going to be pi over 3 plus n pi. Sorry. Is it n pi? What's it going to be? You guys tell me. Since it's not opposite quadrants, what do I need to do? To get every coterminal solution, don't I have to add a multiple of what? 2 pi, not 1 pi? I can go the other direction to get the quadrant 1 solutions. To get all quadrant 1 solutions, I have to add multiples of what? 2n pi. N is an integer. The same thing for the second solution down here, right? So if I said to you guys, all right, what about this? Our solution's at 5 pi over 3. How do we get all the other quadrant 4 solutions? I have to rotate this how? 2 pi? In either direction? So you take 5 pi over 3 plus 2n pi. This is just for positive cosine. But notice, don't we have these other solutions for sine? 0, pi, and 2 pi. Is that right? So you might say, what do I do? Well, look at these solutions here. 0, pi, and 2 pi. So isn't it true isn't that 0 degrees? And there's the next solution, which is over here. Sorry, let's try that again. Here's 0 degrees. Here's what? Pi. And then over here is what? 2 pi, right? So let me write it down that way. This is where x is 0 and x is 2 pi. I have another solution for sine being 0. This happens when x is what now? Pi, is that true? X is 0, x is pi, x is 2 pi. So how can I generally describe this situation? What did you guys do this weekend on this? Right? So if I started here and said, okay, this will be x3 now, what's the deal there? What do you guys think? This is going to be now what? Don't I get opposite and then the opposite direction? Right? So 0 to what? Pi, or even minus pi. So what's the story? I just have to add integer multiples of what? You say, is that 0 plus n pi, Mr. Judge? I can say 0 plus n pi, or I could just say what? 0 plus n pi, isn't that just n pi? And that is when n is a what? Integer. So, ladies and gentlemen, this is using algebra again to get these solutions here. Okay, easy peasy lemon squeezy. All right. All right, tangent squared minus 1 now, ladies and gentlemen. Here we go. So what do you guys notice about this one, by the way? You have power what there? Power 2, is that true? Okay, so I'm going to have you guys try this out for a few seconds here. See what you get, and I got to log on here. Okay, so let's see. What'd you guys do here, right? You're going to add 1, and you end up with what? 12n squared equals 1. Is that true? Okay. Have you seen this before today? Using a little bit of algebra. What are you going to do here? You're going to let t be what? Tangent. So the algebra you get now is t squared equals 1, which means t is plus or minus square root of 1. Is that right? By the square root formula? So that means t is plus or minus 1 because the square root of 1 is 1. So t is positive 1 and t is negative 1, ladies and gentlemen. So notice what you get now here again. You're going to get tangent of x is positive 1 and tangent of x is negative 1. So we're going to get that situation like we started with. In one case, tangent's positive. The other case, tangent is what? Negative, right? You guys okay with that? All right. Okay. So just like before, we got to go to the reference angle for the positive angle. So for the reference angle, tangent is positive 1. We put that as 1 over 1. Is that right? And you get your reference angle here, 1, 1. What special triangle is this? Do you guys know? All right, isn't this going to be what? Square root of 2. What's your angle? Pi over 4, or going to be what? 45 degrees. Is that right? Okay, so just like before, we got to bring in all students take calculus. Remember, you got tangents positive and tangents negative. Just going to bring all those in. Hey, can't seem to bring them in. Come on. All right. 45 degrees. You guys okay with that? All right, here we go. So tangent is positive in quadrant 1 and quadrant 3 here. So we are in the situation where we have opposite quadrant solutions here, right? This is pi over 4 for the reference angle, and then this is pi over 4 for your same reference angle. Okay, so what are we going to say here? Do you guys know? Very easily, just say what? It's very simple. Right? The reference angle is the angle for quadrant 1. So your first solution and your next solution for positive tangent, we could just say pi over 4 plus what? Plus n pi. Because this here is going to be what? The opposite quadrant solution again. Opposite quadrants. All right, you guys okay with that? And that's when tangent is positive. Where is tangent now? Because we did this. This is tangent's positive. What about tangent being negative? What does that mean now? Tangent is negative where? Quadrant 2, quadrant 4. Is that true? I'm going to get rid of this. We got to find that solution. So how do I get the quadrant 2 solution? Isn't that pi minus pi over 4? All right, so do your algebra. And what do we get? What's that solution going to be? Isn't that going to be just really what? Isn't that 3 pi over 4? So notice again, I don't even have to find the next solution, do I? Why? Because the next solution, the next negative solution for tangent, isn't it in opposite quadrants? And that differs again by how much? The multiple of pi, because we have the opposite quadrant solution. So all I got to do now is like before. I took the first solution. Now I get this first solution for tangent being negative, which is 3 pi over 4. And all I got to do is notice that my other solutions are in opposite quadrants here. So I just have to list these two in general. And of course, you always want to say n is a what here? N is a what? Integer. Okay, you guys okay with that? Easy peasy lemon squeezy. All right, n is an integer now. Okay. And that's all you got to do, because they want you to find the general solution, which is all solutions here. Just using a little bit of algebra for some of these here. Okay, now let's take a look at this one. What kind of algebra do you guys think you're going to use on this? What do you guys think? Right. What are you guys going to do now? You're going to add what? 4 to both sides. Is that right? And now you get what? Cosecant is 4. So this is cosine squared. Is that right? Is 4. You let t equal what? Cosecant. So that t squared is 4. Okay, so this is when we get to use our what again? The algebra. Now, what algebra are we using here? Do you guys know? Use t will be what? Plus or minus square root of 4, which means t is going to be plus or minus 2, right? And that's by the square root formula again. So don't forget, the algebra we used here was the square root formula. So that means t again, it's, in one case it's going to be what? Positive, and the other case it's going to be what? Negative for you. Okay. All right, folks. Now let's see what happens now here. What was t? Wasn't t cosecant? So we're going to say cosecant is 2 and cosecant is negative 2. What does that mean? Do you guys remember? If I put the reciprocal, 2 over 1, and a negative 2 over 1, what does that actually mean? Right? Doesn't that mean, don't we have to take reciprocals? That means sine is what? Is 1/2. And sine is negative 1/2. So now we got both positive and what? Negative. So sine's positive 1/2. Sine is going to be what? Negative 1/2. Okay, you guys okay with that? Did we do this earlier? Sine's positive 1/2? I don't know if that sounds familiar to me. No, we didn't. That was 1 over the square root of 2. Okay. Sine is positive 1/2. Okay. Okay, so let's go to the reference angle. We got to see what special triangle this is going to be. Is that right? So the definition of sine is, I think it's what? Adjacent over what? Hypotenuse. That makes this, opposite over hypotenuse, right? Is sine opposite over hypotenuse? I don't remember. Is that what it is? I think so. So that makes this side over here what? The square root of 3. Is that right? So what angle is this going to be now? Do you guys know? I think this looks like to me what? What special triangle is this? Is this 30 degrees? Isn't that pi over 6, 30 degrees? Is that true? What do you guys think? All right. Now this is where sine is positive and sine is negative. Is that true? Right? I mean, this is a reference angle. So if we go back now and say, okay, all students take calculus again, let's bring this, all this information in. $30 degrees, pi over 6. So sine is positive. Let's find out. Where's sine positive again? Quadrant what? Quadrant 1, quadrant 2. So the angle is 30 degrees. This angle is, remember this reference angle, right? That's pi over 6. That's 30 degrees. How do we get a quadrant 2 angle again? We take pi and we subtract the what? Reference angle. So what do you get here? Don't we get what? Isn't this 5 pi over 6 here? We put that out. Let's put that over here. Maybe I hope we don't. Yeah, I hate to say it. There we go. So this is we're gonna have to put it up here, okay? So I want you guys to see this relationship again here, okay? Pi over 6 and 5 pi over 6. This is not opposite quadrants for sign being positive, okay? You guys okay with that? These are not opposite quadrants. But let me remind you guys something here. This is going to be interesting. This is where sign's positive, but where is sign negative? Isn't sign negative where? Quadrants what? 3, quadrants 4. Sign's negative. Here. And where? Here. So here's my reference angle. So this is the quadrants where sign is negative here. But you want to know something very interesting? What's interesting here? Why can I stop here and say that I have all these what? I have all the solutions. Why is it I can stop here? Do you guys know? Take a look at what I'm doing. Okay, I can stop right now, ladies and gentlemen, and give the general solution. Why? Even though sign is negative in quadrant 3 and quadrant 4. Why can I just stop right now? Do you guys know? You see this solution and this solution? They're in opposite what? Quadrants. Is that true? So I can say, hey, take that first solution of pi over 6 and add a multiple of n pi, because again, right in here, the opposite quadrant situation is happening. That's pi. They differ by pi. And I could now say, take the quadrant 2 solution, because the same exact thing is happening for that solution. And you say, was that 5 pi over 6? Yes. And just add an integer multiple of what? N pi here, because you take this solution in quadrant 2 and you get the quadrant 4 solution free of charge, because here as well, they are different by pi. N pi. What is n again? N is a what? An integer. So because we have the opposite quadrants going on, ladies and gentlemen, this becomes a very what? Nice kind of question. What do you guys think? Easy peasy lemon squeezy? And that's what I want you guys to know, that these are opposite. If you ever have opposite quadrants that way, 1 and 3 are opposite. 2 and 4 are opposite. You get to do the n pi, not 2n pi. All righty. Let's give you something that looks like this, just in case. Okay, so what do you guys notice you have here? Right? What is this going to be? What do you guys let t be again here? You're going to let t equal what? You let t be cosine, and you now get what? 2t squared minus t minus 1 equals 0. So what do you guys think you have to do here? What do you guys think? What do you do with this? You ever seen this before? What am I doing here? What do you guys think? We're going to have to do some what? We got a factor. Do you guys remember the algebra for factoring here? It's not a perfect square trinomial, but how do you factor 2t squared minus t minus 1? How do you factor that? Do you remember your factoring technique? Remember the crisscross method? You take what? These two numbers, you multiply together, and that's going to be -2, I think, right? You guys remember that? And then the number here is a -1. So this is where the product of AC and the sum. This is going to be the A value, the B value, and the C value. So you take the product of AC, and the sum is B. Now you need two numbers multiplied together whose -2, but when added is -1. What are those numbers? Do you guys remember? Yeah, it's going to be, one's positive, -2, +1, I think. Right? If you guys remember this process. So you might say, oh, what do I do? Is this going to be, we take this t, we put -2, you take the t, you put +1 here, but this a value here is not 1, if you guys remember that. So you're going to divide both of these here by what? Sorry. You divide both of these numbers here by 2. This is a crisscross method. And what happens with the first one is that's a nice answer, right? That's t minus 1. Over here, you got to bring the 2 up here because it's not a nice integer value. So this is called that crisscross method. You bring up the 2. So this is t minus 1 times 2t plus 1. Or if you already know how to factor that, this is the same thing here. Okay, so this is a crisscross method in case you guys haven't forgotten. Or in case you guys forgot. Two t plus 1, t minus 1 equals 0 here, ladies and gentlemen. So just to kind of remind you guys here of this situation. Anyway, can't seem to bring that down. Okay. So what do you use here again? Do you guys remember? What do you guys use here? What is this? What was this called earlier today with the algebra we did? Some of the algebra, what was that called? Do you guys remember? You guys should. We talked about it. What does this equal? You guys remember? I bring out the box here. What does that mean? We called this something earlier today. What was that? What was that known as? Zero product rule. Thank you. So 2t plus 1 is 0. T minus 1 is 0, ladies and gentlemen. The zero product rule. Full circle. Subtract 1. 2t is -1. Divide both sides by 2. T is -1/2. Add 1, and t is 1. Okay, so don't forget what was t to begin with when you did the substitution. T is cosine. Okay, so this is, again, the two solutions here. So for cosine here, notice cosine here is negative, ladies and gentlemen. It's negative. So you go again to the reference angle is the positive quadrant 1 angle. And you use again the definition of what? Cosine. Isn't that adjacent over hypotenuse? So this is 1, and this is 2, and this is the square root of 3. So it looks like the angle is 60 degrees. That's the reference angle. Okay? Because that's going to be the special triangle. I know my triangles look horrible. Look at that. Is that true? You guys okay with that reference angle? And then cosine is 1. How do I find that angle? That's not even a reference angle situation, if you guys remember. I don't want to draw it there, but okay. Where's cosine 1? Do you guys remember? Yeah. Okay, I'm going to have to draw a smaller picture. So I'll draw a small picture of it. Oops. I think it's down here. That happens when x is 0 and x is 2 pi. Is that true? 1. Oops. Can't make sure that line isn't there. Negative 1. Okay. So this is where cosine is 1. All right, let's figure out the general solution of this here, okay? So my reference angle is 60 degrees, pi over 3. Cosine is really what? Negative. So I got to bring in my all students take calculus picture. Just when I get to it, it disappears. Okay. What quadrants is cosine what again? Negative. Do you guys remember? Where's cosine negative? What quadrants? Quadrant 2. Quadrant what? 3. Isn't that true? And our reference angle is 60 degrees. Okay. It's pi over 3. Reference angle is pi over 3. So let's find this angle. Isn't this going to be pi minus what? Pi over 3. Is that true? So do your arithmetic. 3 over 3. So that means this angle here, we got to put it on top, will be really what? 2 pi over 3. So your quadrant 2 solution is 2 pi over 3. How do we get the quadrant 3 solution? That's pi what? Plus pi over 3. And doesn't that give you what? 5 pi over 3. Sorry, not 5 pi over 3. Isn't that 4 pi over 3? So I just want to point out to you guys, again, I do not have, if I do this here, we do not have what? We don't have opposite quadrant solutions for negative cosine, do we? These are not opposite quadrants. Therefore, for those general solutions, we do have to say what? Add the multiple of 2n pi to get all coterminal solutions. We have to add the multiple of 2n pi, right? Because you are not in, let's go back. We're not in the opposite quadrant solution. These are adjacent next to. So 2 pi over 3 plus 2n pi, and then 4 pi over 3 plus 2n pi. And go back for cosine. What was cosine here? 0 and 2 pi? So you say, what about the cosine 0 and 2 pi? Well, that's actually, both solutions. Right? X is 0. X is 2 pi. So what can we do? What do we do? You could take the what? The 0 solution, and you can add 2n pi. Is that true? Which really is, you say, can I take that? Can I do the same thing? Take 0 plus 2n pi. You can. However, 0 plus anything is what? Is itself. So just say 2n pi. And ladies and gentlemen, n again is an integer. So when you look in back of the book, you should see all of these what? Solutions here. Okay? Now, remember, you might say to me, hey, Mr. Judge, where can I see some other examples? Because I want to see more examples here, right? Well, go to the worksheet here. I'll put this in the chat for you guys. So if you said to me you wanted to see other examples of this, well, I do have other examples. It's going to be where? Go all the way down to what? Trig equations using some what here? Algebra. To do that, trig equations, algebra. All right, you guys okay with that? All right, and I think your homework's already in Canvas, right? If I go over here. Nope, it's right there for you guys. Okay, let me double check here. Let's see. Yeah, okay, whatever. All right, ladies and gentlemen, take a look at that, and we'll see you guys when? Tomorrow. All right, have a good day, and we'll continue tomorrow.